So this is the another instrument which is used in experimental physiology, which is called as induction coil, or sometimes to give due credit to the scientist who invented, so it's also named as Du Bois Raymond Inductorium. Okay, so it was invented in the year 1849. Okay, so it's a simple instrument which is used in experimental physiology. So it is a junction between the primary circuit and the secondary circuit of the experimental setup. Okay, so main mechanism of working is that is a simple device which converts a galvanic current into a Faradic induced current. Okay, so for experimental physiology we need experimental currents which are of low volt, so we convert this into a Faradic current and we do the experiment. So what happens, it works on the principle is that when a current is flowing on one particular circuit, another circuit which is not connected to the directly connected to the power source, if it is moving parallelly or at an angulation, okay, with respect to the circuit which is having a power, due to Faradic principle, it will again generate the current in this circuit. Okay, so it works on this circuit. Okay, so basically in this inductorium, from this particular part the primary circuit is connected, and from this part the secondary circuit is connected, on which the tissues, the nerve muscle preparation and whatever do experimental tissues you are using, you are going to get the tissue. So basically you are not damaging the tissue by using this instrument, so you are giving a little small ampere of currents and you are doing the experiment. So this is the instrument called as inductorium. So let's learn about the parts of the instrument. Okay, so it's a rectangular looking instrument. It's an instrument made of wooden and metallic parts. So it looks like a rectangular parts made of some coils and some metals. Okay, so this part is called as the Neves hammer assembly. Okay, especially this part, this T-shaped plate you can see is moving, it's called as the Neves hammer. Okay, so it's called as the Neves hammer, and the Neves hammer, you can see it is connected to one screw over here, over which a wire can be connected. Okay, or you can just tighten the screw. As you are tightening the screw, what happens, the contact of the Neves hammer becomes very firm. Okay, so this is the called as the screw or terminal for Neves hammer. Okay, so this is called as the Neves hammer. The whole setup is called as the Neves hammer assembly, and this is the screw for the Neves hammer or terminus for the Neves hammer. Okay, then we have some pillars over here. Okay, so this is the induction coil over here. So some induction coils are also attached with the pillars. Okay, so this is another pillar, this is another pillar. Okay, now in this Neves hammer assembly, so these 2 points you can see on which the electrodes are connected, okay, to the primary circuit. Okay, this is called as your input point of the inductorium. Okay, input terminals for primary coil. So as you are connecting the power source with this instrument, so the electrical current is flowing through this coil. Okay, so this is called as your primary coil of the inductorium. So the primary coil, there are some turns of wires over here, okay, which is encapsulated by some cotton threads. Okay, so this have approximately 200 to 300 turns of coils are there in this primary coil area. Okay, so this primary coil is fixed to this Neves hammer assembly. So moving forward in this wooden plank, this is called as the wooden scale board. Okay, this is called as the wooden base with scale. Okay, there are markings are given in centimeters. Okay, so for this is given in order to check at what point we are making and breaking the circuit. So this is the pointer scale or pointer for the distance measuring between the primary and the secondary circuit. So this obviously a coil which is moving along the wooden base is called as the secondary coil. Okay, now it is also having some coils turns over here, which is again encapsulated by a black tape. Okay, so approximately manufacturer coils the fibers approximately 7,000 to 8,000 times. Okay, so there are 7,000 to 8,000 times of coils. Now this 2 points on which we connect the secondary circuits over here. So this is called as the output point are called as the output terminals of the secondary coil. Okay, so this is called as output terminals. So as we are decreasing the distance, so we are going to increase the current over here. As we are increasing the distance between the primary and the secondary circuit, what happens, the current that is generated in the secondary circuit will be, or secondary coil will be less. Okay, also we can increase the angulation between the primary circuit and the secondary circuit. That also will decrease the magnitude of the current that is generated. Okay, so that's BOIS inductorium for you.